Hello and welcome to another episode of How to Code a Game Like Minecraft in Unity. In this one we're going to be tackling trees. Before we get into it though, there's just a couple of things we need to have a look at. The first of which is, since the last video I've upgraded Unity, and if we have a look in console here, we can see there's a whole load of errors. For some reason, these errors are to do with TextMesh Pro, which I'm not sure why that's causing problems with this particular project, seeing as this project didn't have TextMesh Pro installed. But if you do happen to upgrade your Unity and come across this same problem, the way I've dealt with it for now, seeing as we're not using TextMesh Pro, is to go up to Window Package Manager and get rid of it. And as you can see, all those errors are gone. I've not bothered to look into exactly why TextMesh Pro was causing problems, because like I say, we're not using it. If we were going to use it, I would obviously try and figure out why. The next thing we need to look at is, I'll just quickly run the project. Now, this probably won't work now, because it's not 100% consistent, but you may have noticed if you've been playing around with it, that every now and again, you get some kind of weird index mesh error. Oh yeah, see, it's not going to do it now. But what was happening, I'll try one more time to just replicate it. I really would rather show you the error before fixing it. There we go, right. So this error down here, failed setting triangles, some indices are out of bounds. That error is because when we created our we'll just go into chunk here. When we created our transparent triangles array to hold on to the details for the separate meshes that were going to be transparent, I never actually put a reference to it in here. So when we're clearing all our mesh data, we're not clearing the transparent triangles mesh. So to fix that indices out of range, we're just going to add in here transparent triangles dot clear, and that will fix that problem. So now that we've dealt with those, we can get on with the actual tutorial. One thing we are going to do, because we have to add another block, I don't want to just keep changing, no, that's the icons block, sorry. I didn't want to just keep changing this to shuffle blocks around. So I've gone ahead and made a 256 by 256 version of the atlas that will obviously be available in the download to go with this. But basically this is the size of the regular Minecraft, or at least the original, I think, Minecraft texture pack. So the main difference about this is obviously there's 16 blocks across and 16 blocks down. So we are going to have to modify our script to accommodate that. And the reason I'm doing, somebody did ask about this in the comments, so this will help them hopefully. So if we go into voxel data, texture atlas size in blocks, we just want to change that to 16. And then obviously we want to actually set our materials to it. So our materials were blocks. We go up there and we find block atlas, and then what was the other one? Transparent blocks. Obviously we want them to have the same texture, otherwise that will cause all kinds of problems. And obviously when I brought the texture in, I set it to clamp point, no compression, and max size 256, and alpha is transparent. So with that in mind, we are ready to go. Let's go into our scripts folder and we're going to open up our voxel. No. We're going to open up our biome attributes file, and we're going to add a few more values in here. So if we just, we'll create a little header just to separate these values out, and imaginatively we're going to call it trees. And then we want 2 values for now. We'll go a bit at a time. I'm going to call it tree zone scale and tree zone threshold. This will make a bit more sense in a minute. Just because I've been playing with these values when I was getting ready for the tutorial, I'm going to give them some defaults so that I don't forget what they are. So save that, and then we want to open up our world script. And in our world script, we're going to go down to our get voxel. If you remember, this is the heart of the world generation algorithm. This is where all the magic happens. And we're going to add another pass. So remember, we've got our first pass, which is just the basic terrain pass, and then we've got our second pass, which is what, in this case, it adds ores. We haven't got any ores yet, but I think it's just adding a load of dirt at the minute. So we're going to go down here, we're going to create another pass. We're just going to call this one tree pass. And then in our tree pass, we're just going to first off say if ypos is equal to terrain height. We don't want trees below the ground and we don't want them floating above the ground, so we're only interested in this particular position if it is at terrain height. And then within that terrain height we say if noise.get 2D purlin, and then we'll pass in our current position. And then we want this, if you remember, the offset is entirely up to you. All that you want to do is make sure that it's always the same. So if you change the offset, hard code it, or make it something that can't be changed by the player, because if that value gets changed mid-game or anything like that, it will cause problems with the world generation as you move through the world. As long as it stays the same, like you can change it from game to game, but as long as it stays the same once the game is running, it's not a problem. But if you change it mid-game, it can cause problems. So I'm just going to leave it as 0. But like I say, if you want to give it a slightly different value, you can. It's just where it samples the purling noise from. And then we want to pass in our biome dot tree zone scale. And then so we're saying if the value we get out of that, and remember that value is going to be normalized, it's going to be 0 to 1. So if it is greater than, and then we're going to pass in our threshold value. So if it is greater than that threshold, we will set our voxel value to 8. No, 1. We'll set it to 1, which is bedrock as far as I remember. What this is doing now is this is essentially establishing a placement area. So a forest, basically. So if we press play now, you can see we've got patches of bedrock. I'll just come out of 2D here, and we'll go to an overhead view. There we go. So you can see we've got these patches of bedrock. Like I say, mess around with these values all you want. I'm just going with some values that look good enough for my liking for this tutorial. I only want to show you how to do it. I don't necessarily want to go through in great detail how to create a good looking forest. This is just how to get you on the path. So these patches of bedrock, they're representing where the forests will be. So now within that we need actual trees. So the trees are only going to be placed where those bedrock patches are. Obviously we're not going to leave bedrock patches there. That was just to visualize it so you could see what was going on. So if we go back into our biome attributes file, we're going to add another couple of values, and these threshold value, and there is going to be another threshold value, they're always going to be 0 to 1. So we can make that a range value, just, you know, so it never, well, it doesn't want to be 0 at all, so we'll go 0.1 to 1. As it never wants to be more than 1, it's never going to return more than 1, so there's no point in having it more than 1, and it's never going to be lower than 0, but 0 is no use to us. 0 would be entirely, there'd be no patches of bedrock, and 1 would be all bedrock. So these we will call tree placement scale, and these are going to work in exactly the same way. And again, I've got some default values in mind, so I will use those. If I could remember what they were, 15. And then once again, you know what, let's just copy this. Placement threshold, and this one we want to be 0.8. And then we're not going to need it for a little bit yet, but we'll also set a tree size int. 12 we'll go with. Right, and once again, all these values entirely up to you. Mess around with them to your heart's content. These are just the ones that I landed on. So if we go back to our world get voxel class, and we're going to edit these to incorporate these values. No, sorry, edit these to incorporate these values. We're already saying that if we are within a tree placement zone. We're just going to turn the ground at that position to bedrock, just to show us where it is. And then also, once we're in that zone, we're going to do a second sample. I'm going to say if noise.get2d Perlin, and just copy all of this. And again, this is a situation where you might want to mess around with the offset just to get a different value. And you could put an offset value in here so that you could change it easily. Again, the important thing is that it doesn't get changed during the game. So if it's greater than that threshold at that position, then we're going to set it to 8, which I think, if I remember correctly, is bricks. Now if we run our code again, now you can see we've got little patches of brick in amongst our bedrock patches. So, like I say, play with these values, get more trees, less trees, bigger patches, whatever it is that you want. I'm just going to get you started on how to put them there in the first place. So what we could do here is we could tell the code to pass out a value that is 1 block higher than this and set it to a wood block, which would be fine, except the tree is not just a 1 column of wood. Basically, it's going to go up and so far in all 1 column, which will be fine, but then the trees are going to spread around. The leaves are going to spread around, sorry. And the problem with the leaves spreading around is that the leaves are probably gonna, at some point, almost guaranteed to cross over into another chunk, which is what makes things quite complicated. So let's get started on. We'll put this class in here. No, we won't. We'll put it in here. So we need a new class. No, that's inside that class. This is how we're going to handle it, and I'm sure there's other ways of doing it. This is just the way that I've managed to suss out. And we're going to call this Voxel Mod. It will keep a vector3, we'll just call position, and a byte. And we need a constructor for it, so that will be public Voxel Mod. It takes in a vector3, which we're just going to call underscore position, and a byte, which we're going to call underscore ID. And just in case it ever is necessary, we're just going to create an empty constructor as well. And that will just set position to just a new vector3 and byte to 0. I don't think we need a, not byte, sorry. Don't think we need a, I don't think we have a use case for this in what we're going to do today, but just in case. So then if we go to the top of our world function, we're going to create a list for this. Actually, we're not going to create a list, we're going to create a queue, because I mean part of the point of this tutorial is to help people who aren't experts. So I am trying to use different functions and features and stuff to at least, regardless of whether it's the best way to do it, it introduces you to a new concept. So we're going to use a queue, which if you are not familiar with is very similar to a list in the way you set it up. So you type queue, and then in the brackets we're going to put our data type, which is the type that we've just created, and we're going to call this modifications. And the reason we're calling it modifications is because these are modifications to the basic structure of a chunk. So we have our terrain and our air blocks and everything like that. That's the basic structure. These are on top of that. Well, that's basically what a tree is. It's a modification to the chunk. And if you had a village, a hut, something like that, a canyon, or a cave, well, not necessarily a cave. Cave could be considered the basic structure. But basically anything that can't be covered by a single block is a modification. And what I mean by single block is if you sample the get voxel algorithm at any point in the world, it can give you either terrain, a type of terrain, or an air block or whatever. It can't give you a tree leaf because we don't know where those tree leaves are going to be until we generate a tree. So you, like I say, you initialize it the same way you do a list, equals new queue, Voxel Mod. What a queue does is you can't access a queue like you can access a list. You can't say, I want to look at item number 23 of a queue. What you can do is you can add items to the queue and remove items from the queue, and it's a first in, first out scenario. So basically, whatever the first item is in the queue, that will be the next one that gets removed. So we'll get to actually adding and removing stuff from it shortly. You know what, actually, let's just so you can see it in action. If we go down to get voxel, wherever it is, here, right. We'll leave our bricks and bedrock blocks in place for now. So if we type modifications dot unqueue, and what this does is it adds an item to the list, and the item that we're going to add is a new Voxel Mod pos.x pos.y plus 1, because we want it to be on top of the terrain, we don't want it to be in the terrain, pos.z, and then the ID, I think wood is 6. Oh, sorry. There we go. So that's just going to add that to that particular queue. And the next thing we want to do is go into chunk, and we're going to have to create a method for dealing with these modifications. First off, we're going to need a public queue, much like the one we've just, identical to the one we've just created in world. Voxel Mod, and we're going to call it modifications, just like we did before. And it's imperative that this is public, because this is going to be added to directly from the world script. And then if we go down to update chunk, in here we're going to put while modifications.count is greater than 0. So this loop will continue until there are no more modifications left. I'm going to create a new Voxel VOD, which we'll just call V for, doesn't really need to have a semantic name for what we're doing. And it's going to equal modification.dq. And what that does is it takes the first item in the list, so whatever is the top of the list currently, it sets our voxel mod to that, and then it removes it from the list. So that item is no longer in the list once this line of code is run. So we're going to set vector3 pos is going to equal v dot position minus equal position. And all we do is set our voxel map set our voxel map based on that position to the ID that's in that. And then, like I say, remember when we call this, it removes that from the list. So then it's going to go back round to the top and go again, and it will get the next item that was in the list, which is now top of the list, set it to that, remove it, and keep looping until there's none of that left. We also need to make this public, because we're going to be calling this function from the world class as well. And then if we go back into our world script, we need to create a new list in here, which we're going to call list. This is it's going to be of type chunks, chunk, sorry. And this is going to be chunks to update. And it's obviously equals a new list. And if we go down to our generate world script, we need to make use of all this. So we're going to do similar to what we did in the chunk script while modifications dot count is greater than 0. So once again, it's going to carry on looping until we've got no more modifications left. So the first thing we're going to do in this loop to ensure that we do reach a point where there's no modifications left, because obviously we don't want to get stuck in an endless while loop. It's worth noting that we are placing this loop in a point in the code where nothing else is going on at the same time that involves this modifications thing, modifications queue. It would be good practice to ensure that nothing else can be done with this modifications queue while we are messing with it, because if we're saying modifications queue loop through until modifications queue is 0, and then somewhere else in the code in the game stuff is being adding to that list, this could in theory go on forever. So it would be good practice to like lock it, but we're just going to leave it for now because we know there's nothing. This isn't that big a script yet, or this game isn't really that large of a project, so we know nothing is going on at the same time. This is the main loop, the world loop, and we're in the start function essentially. Generate world is called from start, so all this is happening before we ever get to anything else going on. So voxel mod v again is going to equal modifications dot DQ, and if you remember, this is a different list to the one in our chunk. This is the global list as opposed to the specific chunk list. And then we're going to, just to make things a little bit easier, we're going to get a chunk card, which will be v get chunk card from vector3, and we're going to pass in v.position. So we get the chunk that is associated, the chunk that this voxel mod will apply to. Before we do anything with it, we want to make sure we actually have that chunk. So the reason we're doing this in this part here is because we're only generating the chunks that are within the view distance to start with, but if there is a tree on the border of that view distance that crosses over into the next one, we need to add that data anyway as well, because the tree algorithm only works from where the tree starts, like the trunk on the land, on the terrain. So even if the chunk isn't generated, if the chunk's on the border of the generated land, we need to be able to add this data to it, because this data isn't going to get added through the voxel algorithm. Because it's only adding the one voxel, the start position of the tree on the ground, essentially like you think of it as a sapling in Minecraft, it's only adding that one position. We need to make sure that the information for the rest of the tree gets given to the chunk. So we need to check to make sure we're not looking at a chunk that is outside of the generated world, and if it is outside, we need to add it. So we'll just do a quick check. If chunks c.x c.z is equal to null, that means that it is not generated. Then we want to, first off, c.x, c.z. First off, we want to generate it, so put new chunk, pass in this chunk card. This is the world reference, and then we're going to say true. We want it to generate straight away. And then we will add it to the active chunks list so that it gets added or removed as necessary once the game starts running. Is there any chunks that we add to the game need to be in the active chunks list, because otherwise they won't get removed when we move out of view distance of them. So once we've done that, whether the chunk was already there and generated or not, we have now got a chunk. So using that chunk, we're going to unqueue our voxel mod. So now we're putting this voxel mod here into the modifications queue for that specific chunk. And then we're just going to check if chunks to update does not already contain. I'm just going to copy this because I keep mistyping it. If it does not already contain this value, then add this value. And then once we've done that, the last thing we're going to do is go through that chunks to update list. And we're going to do it this way. I equals 0. I is less than chunks to update dot count I++. And we're going to say chunks to update. No, actually, just 0 every time, because we're going to remove it from the list once we've done it. So this is kind of like work. This is very much working like the queue, but the reason we're not using the queue is because we need to be able to check whether something is already in it, and we can't do that with a queue. So this needs to be a list so that we can use the contains function here. So that's why we're not just using the queue to do, because then we could do what we're about to do now in 2 lines. With a queue, we would do it in 1 line. So if we go over to our game and hit play, we can see we've got some tree stumps. We do have a few that aren't generating on time, but we'll be able to deal with that if we... It has done the data side of it. If I place a chunk now and force this chunk to update, you'll probably see that the stumps will reappear. Yeah. What's happening is it's getting skipped over in the actual update loop, but the data is getting added to it. It's just, for some reason, it's not updating it in the start. Oh, and by the way, I don't think I pointed this out. The reason that we're doing this this here is because if we don't, it will update. It will add the chunk to the chunks to update list every single time there is a voxel modification. If you think one tree's probably got about 50 voxels, so that would be 50 updates per chunk, per tree per chunk. So this is to ensure that we're only updating the chunk once for every, regardless of how many voxels there are in that chunk. So now that we have a functional tree generation system, we're going to make the actual tree itself a bit more tree-like. So we're going to create a new class which we're going to call structure, and the reason we're calling it structure is because we're going to think of the tree as a structure. This class will handle anything else that you could consider a structure, so that could be a village hut, or I'm trying to think what else there is in Minecraft, a mine, anything like that, anything that's not part of the basic terrain generation, that can't just be generated on the fly, that you need to add. Like, you could think of it as a prefab, really. And it's going to be static. And we're going to call it make tree. And it's going to take in a vector3 position. And it's going to take in a queue. And that's it. That's all it takes in. Because we need to tell it what the queue is called. It does need to take something in, sorry. It needs to take in an int min trunk height and an int max trunk height. So the first thing we want to do is get the height. Now, we can't just use a random... I mean, we could just use a random value, but the problem with the random value is we've initialized the random state machine in this code. That was, I think we did it up here. Yep, so we've initiated the random state machine. We're always going to get the same sequence of random numbers. So, in theory, if we said, give me a random number between 4 and 7, it's always going to give us the same random number at the same point, but we can't guarantee that that point's always going to be the same. So if we generate a chunk and while we're waiting for that chunk to generate, we go off and do something else and then come back to this one. Say one machine is faster at generating chunks for whatever reason, that machine might get back to this quicker than the other machine, and they're going to come up with 2 different random numbers. So one way we can get around this problem is first off, we're going to call this height. And what we're going to do is we're going to use Perlin noise again. So max trunk height. Because if you remember, Perlin noise gives us a value between 0 and 1. So if we times our max trunk height by that value, we're going to get a value between 0 and the max trunk height. Because, for example, if the max trunk height is 12 and we times it by 0.5, we're going to get 6. That's how we're going to do it. and no, remember the name of your own functions. Noise.get 2D purlin. And obviously we need to always give it the same values relative to, like, if we give it two different positions, like if we just pick two random numbers, then we're going to have the same problem all over again. So we need to give it the actual position of the tree, because then it's always going to be the right value for this tree. The offset, again, it doesn't really matter as long as it's always the same. Let's just give it 250 for this one. And the scale, I think I just put 3 last time. It seemed to work out fine. Again, it doesn't really matter, but I think the higher the scale, the more variation you should get. But then also we want to do a check because we don't want any 0 length trees. So we'll just do if height is less than min trunk height, then height equals min trunk height. And now that we have that, we'll do a quick little for loop. For int I equals, we're going to start from 1 because we're going to be passing in the terrain value. Like the get voxel command, or the get voxel algorithm is going to be working at the exact voxel that it's looking at, and the voxel it's looking at is going to be the one below where we want the tree to be. So we're going to start off with 1 rather than 0. I wants to be less than height, and obviously we're only incrementing 1 at a time. And then all we're going to do is q.onQ new Voxel Mod, new vector3 position.x position.y plus I position.z, and this wants to be 6, no 7, no 6, yes 6. 6 was wood. Yeah, 6. I know what I'm talking about. And then we go back to our world, blah de blah, get voxel. Sorry if I sound not with it tonight. I'm a little tired. And then instead of this, we're just going to call our structures. Did I not make that public? Public static void. I did. Structure, not structures, sorry. Make tree, we want to give it the position, which is just position. The queue, we're going to pass in the modifications queue. So it's going to be altering that queue. And then for our minimum and maximum height, we can get that from our biome because we added that value earlier on. So if we run the code now, we should find we've got a bit more to look at. As you can see, we've now got some tree trunks. And we still have certain places where it's not being generated, but we will deal with that. And then if we go to our world thing, we can add ourselves a leaves block. So I want 12. The leaf texture is the last one, so that's going to be 16. It is solid. It is also transparent. I haven't got an icon for it just yet, but it's not really important for this. And then if we go back to our structure, we'll just copy this. I want to set plus height and is it 11? Yeah, 11. There we go. We have our leaf blocks. Now we need to actually make them into a tree-like structure. So I'm not going to go into making the trees sort of random shape at the minute. For now, we're just going to just make a square leaf structure on top. So easiest way to do that is for int x equals, now these values, again, you can mess with all you want. I'm just literally placing a cube of leaves on top of the tree trunk. So you can add some randomness to it if you want. I don't want to get too bogged down in specific little details like that, because I feel like from everything I've shown you, you should be able to figure that part out at least. X is less than 4, so we're going from -3 to 3. X plus plus. And then we'll just copy that. And we want to change these to Y and Z. And Y, instead of going from -3, wants to go from 0 to 7. And then if we copy this again, we're going to be putting position.x plus x, position.y plus y, and position.y plus height plus y, and then position.z plus z. And that should be all of that. There we go. Right, so our next problem, in addition to not 100% generating everything, or not updating everything straight away, we also, if I just zoom out here, and I run off in, which way do I want to be facing? This way, yeah. If I run off in this direction, you'll see that we're also not generating trees on new chunks that have been generated, as well as the few that have been missed. So this is where it starts to get a little bit tricky, if it didn't already seem tricky before. So if we go to, we'll go here. This seems like the best place to put it. We're going to create a couple of new functions. The first one we're going to call create chunk, not create chunks. You'll notice we've already got a create chunks function down here somewhere. We're going to be getting rid of that. But for now, let's just create this. Chunk code C equals chunks to create 0. Again, it's getting the top item in the list. And then we want to remove that item so that we don't do it again. We're going to add this chunk to the active chunks list. And then we want to initialize it. That's all we need to do in that function. And then we're going to do a function for updating chunks. Now this one's a little bit more involved, so we're going to set up a bool to start with. Updated equals false, and then we want an index. And then we're going to do a while loop, and this while loop is going to keep going until updated is no longer true, is no longer false. And the reason we're doing this check is because it is entirely possible that we're going to hit a chunk at the top of this list that is not ready to be updated. So the first thing we do is check chunks to update index dot is voxel map populated, because if the voxel map is not populated, then the chunk is not ready to go. So we need to leave it for now. If it is not populated, if it is populated, then we're going to update it. we're going to remove it from the list. And then we're going to set updated to true so that we exit out of this while loop. However, if it's not ready to go, we're going to increment index and then loop around again. And the reason we do that is because we could just tell it to only just have this if statement alone, and then it wouldn't do it if the chunk wasn't ready to go, and then it'd just exit. But that means that we'd be sending a call to this function and not doing anything. So we increment the index and then we go around again and we check the next item on the list. And for that reason, we also need to make sure that we're not checking an item greater than the list. So also, if index is less than chunks to update dot count -1. So now if we go down here, we're going to delete this. We don't need this anymore. And if we go up here, we also don't need this. However, we do need a new bool, which we're going to call applying modifications. So we'll go, obviously we'll need to, we're going to change this in a second. So we'll go back down to where we added these, and we're going to create a new one final coroutine in place of the one we just deleted, I guess. Apply modifications. And in here, first off, applying modifications is going to be set to true so that we know that we are currently running this in much the same way we use that bool that we just deleted. And we need a count, and you'll see the purpose of this count shortly. So once again, we're going to do a while loop while modifications.count is greater than 0. So keep looping as long as we have something to loop through. Voxel Mod v equals modifications.dq. Basically, let's just copy it out of the first part of it is very, very similar to what we did here. However, where it differs is that we are going to be breaking out of this every so often, because otherwise this would really cause the game to hang up. So we're going to increment count here, and then if count is greater than, and I'm going to put 200, this value is entirely down to you. This is kind of a temporary measure. We're going to be doing further optimizations and stuff to make things run quicker, probably in the next Minecraft episode maybe. But for now, this is just basically, it limits it to running 200 voxel modifications per frame. So you could make this number smaller and it would take less time per frame, but it'd get less done, or you can make it higher and it'll get more done, but it would take longer. So it's just finding a right balance. I found that 200 seems to be a decent amount on my computer. Maybe on a slower computer you'd be happier to have it lag the machine out, not lag the machine out, but have trees sort of gradually popping into existence. So in here we want to put if count is greater than 200, reset count, and yield return null. And then when we eventually get to the end of our while loop, we want to put applying modifications equals false. Now if we go up to our update, we can get rid of this. And we're going to replace it with a couple of calls. So the first one is if modifications.count is greater than 0, and we're not applying modifications already, then we want to start the coroutine. So we're only starting it if, one, we have some modifications to loop through, and two, we're not already looping through them. And then if chunks to create dot count is greater than not, create chunk. And if chunks to update dot count is greater than not, update chunks. So because this function, because these functions that we created here only do, they're not loops, they only do one thing at a time, that means that this is essentially just going to loop through chunks that it needs to create or update, do one, and then let the frame carry on, let the game progress to the next frame. So it kind of works. It just breaks things up a little bit so that we're not creating 10 chunks all at once and freezing the game up while we wait. So if we go have a look now. Now you could see the trees popping into existence. I think you could see them anyway. If I run off in a direction, you can see the trees don't instantly appear with the chunks. That's just the nature of the way they're created. Like I say, that value, the 200 value, you could set that value lower, and then it would, the chunks would appear quicker, but the trees would be slower. Or you could set it higher, and the trees would appear more in, like, if the value, if there was no value, if we just didn't yield that loop at all, then the trees would appear when the chunks appeared, but the chunks would be a lot slower because they would have to wait for the trees. So that's the way that value works. I hope that makes sense. And then, like I say, you could add some randomization to these trees to make the leaves look a little less square, essentially. All of this is fairly basic stuff. It's the complicated part is getting the trees in the world in the first place. So that's going to be it for this tutorial. I think I mentioned in the next tutorial we're going to, actually, you know what we'll do just before we call it a day. If we go back into our world, get Voxel, where is it? There it is. Go into our tree pass. We're just going to remove this and remove this. And then we'll play it again. There, now we don't have the bedrock and everything everywhere. So yeah, that's it. The next Minecraft video, I'm not sure if it's, I don't think it's going to be next week, but the next Minecraft video, I'm pretty sure we're just going to try and do some optimization. Make everything load a bit quicker. I wanted to avoid threading, but we might have to do it. Speaking to a few people on comments, I think the lag of generating chunks is a problem for some people, and it's only going to get worse as we add more things like trees. So that's probably going to be what the next video is about. Or the next Minecraft video, sorry, I've got something else planned for next week. But that's it for now, and thanks for watching. I'll see you next time. Bye-bye.